Okay, welcome back again, and this is the Chipmaster with another repair video. Alright, so today I'm going to repair a laptop here, which is a Dell old school. It's a 2011 laptop. No, sorry, it's a 2013 laptop, I think. Let me see. Intel inside. So it's a 2013. It seems as if it's a 5th gen CPU, which is the Broadwell CPU. Could be a Haswell as well, which is the 4th generation. Alright, so I got it from a tech, and he said that it's a bit dirty at the top here, because he said that he had it put down for about 5 years. So he said that he wanted to see if he could repair it so he could have a sale for this laptop. Right, so he asked me if I can repair it. So he said that it's not turning on. Alright, so I'm going to see what I can do. A little bit more. Is that normal? Yeah, there's about it. Oh, it's okay. Alright, so as you can see, the top is a bit dirty. Alright, so it's a Dell. Alright, so I'm going to open the lid. I'm going to plug in the power and to see what the power consumption is. Alright, so I have there, it goes to, I have standby volt current there, that's roughly 10 milliamp. I'm pressing the switch. Oh, it turns on. 400. Oh, it beeps once. It beeps once. As you can see, there's a one faint beep there, and that indicates that normally it's a BIOS problem. So that beep, I'm hearing one beep. Hold on, I'm hearing two beeps now, and I'm hearing one. It's two beeps. Two beeps, so it's two small beeps. Alright, so I'm going to just want to see here first to see if there's RAM in it. Oh, there's no RAM. So the 2 beep indicates that there's no RAM. So this is normally should be using a DDR3L RAM. Let me see if I find one. Alright, so this is a DDR3L RAM. Alright, so I'm going to try again. Hold on. 2, 3. I'm getting 5 beeps. 5 beeps normally indicate RTC problems. The RTC battery. The RTC is not powered. Alright, so I will continue this disassembly. Alright, so the RTC is not powered. I'm getting 5 faint beeps. They are not loud enough, but if you listen closely or carefully, you can hear I'm getting 5 beeps, and normally that indicates something with the RTC section. Alright, RTC battery not powered, or it's missing, or there's an internal problem inside of the RTC well in the CPU. If the RTC well in the CPU is faulty, you have to replace the entire ULT series CPU, which is the Broadwell. Alright, so all the screws are removed from this side. Now removing the keyboard. Alright. Alright, so I'm just doing my visual inspection as usual. Alright, so since it's turning on, alright, so looking here at the LCD, this is a redriver which is able to process image signals. Alright, all is well there, no burn, no explosion. This chip is faulty, no internal display. Alright, because this CPU, which is the Haswell CPU, only supports the output of EDP signals, right? And this uses LVDS output, so it has to convert from EDP, which is from digital display interface, and this MUX, or you can call it a retimer, which is going to translate or process or reformat this signal, image signal, into LVDS, right? Because these screens are older screen, they don't support the EDP, so this is LVDS. LVDS stands for low voltage differential signaling, right? All right, so this is the EC here. I'm looking at the EC section. Alright, as you can see, the EC, which is a KB9012 or KB9012QF-A4, which is a programmable ROM. Alright, and it has an internal ROM inside, and it is good, no burn, no liquid damage, anything. Alright, looking at the standby section here, this is the standby chip. Alright, TPS 51225, it could be C or it could be B, but this is on a TPS 51225, and this output 3 volts and 5 volts with adjustable output voltages. Alright, so this is the RAM this is the audio codec with integrated amplifier, and we have no problems there. So far everything is good, so I'll continue the disassembly. Oh, if you notice, I see some liquid damage here now. As you can see, I'm seeing liquid damage here, right? And this could be because I'm getting 5 beeps, and that indicates something with RTC. So we would have to confirm with Schematic or board view to see these capacitors and what they are used for in this circuit, if it's for the RTC well or whatever, right? So looking at this side of the board here, these are the output coils, right? P5 volts and 3 volts, all is well there. I think this is 1.05 volts for the PCH and the bus power supply, right? All is well there. All right, up here on the CPU power supply section, there's just one coil, right? That coil there. And this is the CPU core power supply chip. Alright, output 1.8 volts, and this is the DRMOS chip. Alright, so I'm going to remove the heatsink. As you can see, the board is LA. The board is LA9982P. Alright, so I'm going to remove the heatsink. Alright, so looking at this, it's a 5th gen CPU. Alright, so right around that part that I said before, which has liquid intake. Alright, so alright, so right here has a liquid intake. Right, so I'll need to find a schematic. If I can find a board view, that would be good. Right, to tell me exactly what's going on here. Let me check the RTC battery, if it has voltages or not. Yeah. Alright, so I'm checking if I'm getting voltages on the RTC battery here. Zero volts, no voltage. I'll try another one. Try another RTC battery. Okay, so now try another one. Alright, so I have 3.3 volts. Alright, so I'm checking the RTC crystal here. 0.3 volts on one side. And the other side is 0.38. Let me check the other side again. 0.37. And the other side 0.38. So that means I'm getting an oscillation right here, which is good. So I'm going to check and see if I can find a schematic. I want to locate these capacitors that are liquid damage. Okay, so I am on the schematic section. So as you can see here, I have a schematic, and this should be a board view for me, and that's what I want. Perfect, perfect, perfect. So I have a board view and I have a valid schematic. Alright, so let me see. So the error occurs right along here. Right, so as you can see, RTC VCC, and this is the RTC section that was corroded. So this is why. So I need to check here. These are grounded, and these are the capacitors, and these are the resistors. RC7 intruder, and this one is DSW VRNEN. This is the deep sleep voltage regulator module enable. This is going to turn on the 1.05 deep sleep well voltage inside of the CPU, right? And this is PCH internal VRMEN, which is the internal voltage regulator module. This is going to turn on the 1.05 volt suspend regulator inside of the CPU, right? And you can also check back this signal with a signal which is called DCP sus, yeah? So DCP, right? Underscore sus, I believe. Let's see. All right, so let me see. Let me type in DPC first. DPC. Did I type DCP? All right, so DPC. All right, it's normal on this side, so I'll go to the power supply section. Let me go to the next page. All right, so we have DPC. No, that's not it. So SLPS4, this is the power management section. See, system power management. Alright, this is the signal that I was checking, DSWVRMEN, which is pulled up by this resistor, which is RTCVCC, coming through this 330k resistor to provide 3.3 volts for the internal deep sleep well. And this is the power management section, and I need to find the other section where it has this is GPIOs. Alright, let's see. This is USB power supply section and so forth. Let's see another path. VDDQ, that's the RAM power supply management signal. This is the core. Alright, so here it is, DPC RTC. So this is what I was looking for. So the RTC, you have RTC INT VRMEN. Right, so when we give RTC VRMEN, we should get a 1.0 voltage here. When this 1.0 voltage is, this voltage is operated internally inside of the PCH or the CPU, right? So once this voltage is released from this CPU, that means the INT VRMEN section is perfectly fine, right? And that can be found on VCC RTC section. So VCC RTC, yeah, and I'm going to search. So VCC RTC is here, as you can see. This is the main power supply for the RTC section, right? So once we get INT VRMEN, it says INT VRMEN, yeah? So here's it. So the integrated suspend 1.05 volts VRAM, right? So when it's high, it's enabled the internal voltage regulators. When it's low, it enables external VRs. But for this style CPU for Intel, they automatically integrate these voltage regulator inside of the CPU. So it doesn't need an external voltage regulator to provide 1.05 volt suspend voltages. It is already produced inside of the CPU, right? So when we give RTC VCC through this voltage this resistor here, it's normally through a 1 mega ohm resistor, and it is going to send to the CPU, and then it will tell the CPU to turn on the 1.05 volts suspend regulator inside, right? After that, then it will produce DCP EXT, right? DCP sus. Here is it, DCP sus. Right, that's a test point there. We can check here, or we can check here, DCP RTC. So I'm going to check here. If I'm getting 1.05 volts here, that indicate to me that the RTC section is perfectly fine. Let me check. Alright, so I'm going to head over back to the camera. Alright, so I'm going under the microscope. Alright. Just setting up my lighting. Alright, so DCP EXT, which is the external, and it's right under the CPU section here. Let me confirm the position with the, so it has a, alright, I'm just locating the position. Alright, so it's right here. Alright, in focus. Alright, so it is right here. This is the capacitor, and that's capacitor, which is C52. Is that right? Yes. Yes, that's it. So I'm going to check here for 1.0 volts. This is without plugging in the charger. 1.2 volts. 1.2 volts. It's a little bit high, but it's in the range. All right, so oh, sorry, I'm adjusting the camera here. I'm checking it again. 1.2 volts. So the RTC section is powered. All right, so I'm going to fix up this part here. Yeah, they seem nice. All right, the joints are intact, the capacitors are intact, the via is intact. So this part here is roughly 3 volts. Let me check here. 3.3 volts. No, it's ground. This is ground. 3.3 volts is here. 3 volts is here. Sorry, RTC power, and this is ground. So the RTC, it's not of a bad deal. I'll just clean here. It's 99.9. You know what? I'm going to replace these capacitors. If these capacitors are shorted, then you can't get a trigger. So I'm going to replace them because I don't want them to get aged. And then when they age, they tend to crack and becomes a wire, and that's going to cause a problem. The RTC section cannot be powered. So I'm going to replace all 3 of them. Right, these are 0402 capacitors. All right. All right, so I'm replacing it now. As you can see, I'm holding it in a angled position. And that's how you remove a 0402 component. See, just like that. Right, angled position. Okay, so I'll now just add some paste flux here, and then I will place it. Alright, one down. Alright, and this one seems to be a 0603. Alright, so I'm going to insert the REC battery. Alright, so I'm checking now on the crystal. The crystal is oscillating. Alright, so I get 0.304, 0.34 on one side, on the other it's 0.35. Alright, the voltage difference should not be the same. Alright, let me check this again. 0.345, and this side 0.36. Excellent. So the crystal is oscillating. Alright, and here should have 3 volts. Alright, 3.1 volts. Alright, good. Alright, so here is the RTC. This is the germanium diode. Alright, right here we have the germanium diode and the 1K resistor. So the RTC battery leaves from this voltage, from this slot or socket, and it comes to this resistor 3.3. I'm making it go around. 3.2. After coming through this germanium diode, it will have a 0.04 or 0.1 voltage, 0.1 to 0.3 voltage drop. Sorry. See, so this side is 3.3. Right, after conduction, forward bias, right, it will take 0.1 of the voltage. Right, there we go, 3.1. So all is well there. And DCP source, as I said, as we checked earlier, is 1.2 volts, and that's within the range. Alright, so DCP source, oh sorry, it's right here, 1.2 volts. Alright, so the RTC section is working there. Alright, so this is a very important and crucial part of the circuit for the Intel platform. If the RTC circuit is abnormal, then it will not trigger, right? And another signal that is important for the newer generation CPUs, for the 12th gen up, from 10th gen up, right, which is the sus clock, SUS, right, CLK, right, sus clock. As you see, it's not used here, right? Normally this will be sent to the EC, and the EC will turn on the secondary or another voltage, which is a enable signal for the newer motherboards for like 10th gen series and upwards, right? The sus clock is needed, right? This sus clock is generated from the 32.768 kilohertz, right? So it's RTC X1, I see. Sorry, XX. Alright, 32K. No, that's not it. Let's see if I can find the clock. SRTC reset. SRTC RST, yeah. RTC X1, right? So this is coming from here, which is this clock, right? So RTC X1, this is a 32.768 kilohertz. When this starts to oscillate, it will send this sus clock signal back to the embedded controller. This sus clock back to the embedded controller, right? So if I check there for T102, let me see if I can find T102. Alright, it's not found. So it's not important because it's just a test pad. Alright, so I'm going to assemble the unit and see what happens from there. Okay, so I have assembled the unit partially. Alright, so I'm going to give power. You can see the screen. Anyway, I'll show you on the other camera. Alright, so I press the switch. There we go, Dell. We have picture. So alright, so it says no hard disk. Alright, so as you can see there, alright, so there we go. So it's now booting up to Windows 10. Okay, so alright, that should be it. Alright, so it's loading up there. So I hope you enjoyed the video there. At first it was turning on about no display, 5 beeps that indicates something was wrong with the RTC section. Right, so as you can see, the RTC section has had liquid damage there, which automatically drained the RTC battery. Right, so the battery automatically discharges itself, so there's no power, and those caps were maybe leaking, so I had to replace them. So I checked the DCP source. 1.05, 1.0 volts, 1 volt is generated inside of the PCH. The PCH is basically giving that acknowledgement, or it's a reference voltage for the RTC section. Alright, so I hope you enjoy. So I see another video when I repair something for you.